Here we have a tank of fixed volume V, which contains N molecules of the gas. So let's say V is the volume and capital N is the number of molecules. T is the temperature. Now the pressure at Kelvin temperature T, pressure is also given as 20 megapascals. Now N by 4 molecules are removed out and the temperature is changed to 2T. So which means if you subtract n by 4 from the original number of molecules n, so n minus n by 4 will become 3n by 4. So in the same tank, now you will have 3n by 4 number of molecules. Temperature is 2T. Volume, of course, will stay the same because it's the same tank. And the pressure will change to P dash. So all we need to do is just apply the equation PV is equal to nRT two times for case 1 on the left and case 2 on the right hand side. So initially the pressure is 20 megapascals. Let's write 20 MPa. Volume is V. N is the number of moles which has not been given to us explicitly in the question. So how do we find it? In the question, we have been given N, capital N, that's the number of molecules. And remember, 1 mole has Avogadro number of molecules, Na, which is 6.022 into 10 to the power 23. Remember, 1 mole of any gas has Avogadro's number of molecules. So this is Na number of molecules. And if any question it's given, let's say a particular gas has N number of molecules. Let's say capital N molecules is given to us. So how do we find the number of moles? So what do? Number of moles of the gas is equal to N, which is the number of molecules of the gas which is given to us, and you divide that by the Avogadro's number Na. So N upon Na will give us the moles of the gas. So let's put this in this particular formula. In place of N, we will write capital N upon Avogadro's number multiplied by R, and the temperature is T. So this is our equation in case number 1. For case number 2, the volume stays the same V, but pressure is P dash, which we have to find. So let's write down P dash multiplied by V equals to the new number of moles will be again number of molecules which are given divided by the Avogadro's number. But in the second case, since n by 4 molecules were removed out, what is left is 3n by 4. So we'll write 3n by 4 in the numerator and Avogadro's number in the denominator, multiplied by R, multiplied by the temperature in case 2 is 2T. So that's our equation number 2. Now let's simplify these two equations to get P dash. So all we are supposed to do, let's divide equation number 2 with equation number 1. So on the left hand side, we'll get P dash V divided by 20 multiplied by V on the left hand side. On the right hand side, the Avogadro's number Na will get cancelled out, the R will get cancelled out, the temperature T will get cancelled out, and capital N will get cancelled out. So a lot of terms are getting cancelled out on the right hand side. So we will get 3 by 4 divided by 1, which is just 3 by 4. Now on the left hand side, we can see the volume is getting cancelled out. So let's make P dash as the subject. So we'll get 20 into 3 by 4. 4 5s are 20, 5 3s are 15. 15 megapascals is the final pressure in the tank, which is option B. And that's how we solve this question.